The purpose of this video is to show what the assignment is on Concept Builder and specifically trajectory angle launched projectiles. Let's get rid of this. It's worth noting that I'm only having you do this one. I'm not asking you to complete these. Only do this one. So if we do go and try that one, as usual, there's several questions here. There's 6 on this one. I wanted to work through a couple of them to familiarize everyone with the process and look at this. So it says a ball is launched at an angle. Its location is shown every 1 second. It's kind of like a strobe light, 1 second intervals. Which phrases describe the changes in horizontal speed, which is velocity on the x, vertical speed, which is velocity on the y, as the ball moves from B to E. So we have something happening on the x and then on the y. We always want to think about x and y components. So we can think about there's something happening here, and there's something happening here. This is the x component. This is the y component. We see the resultant or the total component here. We see this happening. Let me make that a different color. We see this happening here, but in fact, it's very useful to think about things in the x and the y components, like we've said. So that's what the point is here on the x component and the y on the y-axis and the x-axis. So this is always consistent. Once that projectile leaves and starts flying through the air, it's important to realize, and this never ever changes, horizontal speed doesn't change. And on the vertical, in this scenario, going from A, let me clear the screen here, going from B as it travels up to D, on the vertical, it starts out with some kind of velocity, but the whole time it's moving vertically, acceleration from gravity is acting downward on it. So it's actually slowing down the whole time it's moving upwards. Once it gets up here to the top and as it starts coming back down, well, now it has, like we discussed, it's moving downward, and acceleration due to gravity is still pushing on it. So it's accelerating downward. So moving up, it's slowing down, slowing down, slowing down on the y-axis. Coming back down here, it's speeding up, speeding up, speeding up on the y-axis. So the correct answer would be decreasing the entire time because it's slowing down going from B to D. We can click these if it will let us, and we will see if I am correct. Yay! The other one that's worth seeing here in this question, and there are 6 of these, but most of them are represented by these 2 things we see here, I do believe. In this other question type here we'll see is, it says rank the 3 indicated locations based on the horizontal speed Vx and vertical speed Vy. So Vx should be easy. Remember, whatever's happening on the x-axis, once it leaves the ground, that velocity stays identical the entire time, all the way through. Its velocity is like that all the way through. You should remember that from when we did the PhET simulation. That the x component never ever changes. There's nothing acting on it to make it accelerate. This doesn't have rocket boosters, rocket thrusters mounted on it. There's nothing pushing it or pulling it on the x-axis. So the correct answer for the x-axis is they're all the same. Now on the y-axis, this is something very different. And so here we know it's taking off with something happening, a velocity on the y-axis here. That's really hard to write. Small. Let me clear that. Try this again. So you have some kind of velocity here on the y-axis. Well, at the same time, when you hit the ground, it's going to be the exact equal velocity on the y-axis. It's just going to be in the opposite direction. So from this point here, traveling up to this point here, and then continuing to this point here, where is it moving its fastest and where is it moving its slowest? Well, we can say it's its slowest up here at the top at E, that's for sure. Oopsie. There we go. It's moving its slowest because it's at the top at E. And then here, it's starting to accelerate downward. So its next smallest would be at F. And then its fastest of these options would be at B. So now let's check answer and see if we're correct. And that should represent, we'll make sure, another question here. Yeah, this is a similar question. I mean, they're all a little different, but you should have a good sense of this at this point. Thank you, like, and subscribe.